Hello students, so my name is Rohit Singh and I am from YourPedia, and today we are going to discuss interview questions asked in HPCL exam. So last year they asked a question from soil mechanics in which they asked why do we compact soil. So as you can see from the figure that when the soil is not compacted there is an instability in the structure, whereas when the soil is compacted the stable structure is obtained, right? So let's discuss this in detail, right? So what happens is compaction is the application of mechanical energy to a soil to rearrange the particles and reduce the void ratio. So what happens is we apply a compactive effort on the soil and hence the soil particles rearrange themselves and thus reduces the void's volume and hence the void ratio is reduced, right? So also the compaction occurs when particles are pressed together to reduce the space between them. Also, highly compacted soil contains very few spaces, resulting in soil with higher unit weight. So ultimately we get the higher unit weight soil, right? Also, the maximum density is achieved at an optimum moisture content, or OMC for short, right? So there's a optimum moisture content, water content, at which you get the maximum dry density, right? Okay. So why do we do compaction, right? So what is the purpose of the compaction? Okay, so the principal reason for compacting soil is to reduce subsequent settlement under working load. As you saw in the figure that there is a different settlement if we don't compact the soil. So to reduce that subsequent settlement we do the compaction, right? So this was the first purpose of compaction, right? Let's move on to the second purpose. Also, compaction increases the shear strength of the soil. So as you can see the voids are reduced, so the shear strength is increased and hence the soil have higher strength and hence stable, right? Also, compaction reduces the void ratio, making it more difficult for water to flow through the soil. So what happens is when the voids ratio is reduced, hence the water which percolates through the soil will be reduced because the pores or the space between them is reduced, right? This is important for the soil if the soil is being used to retain water such as would be required for an earthen dam, right? So what happens is earthen dam is the main purpose of earthen dam is to hold the water, right? So if the soil of the earthen dam has many pores then the water will percolate through it, so the purpose of the dam will fail, right? So this so compaction is necessary in order to build earthen dam, right? Also, compaction can prevent the buildup of large water pressures that cause soil to liquefy during earthquakes. So also when the void ratio is less, so the pore water pressure will be less and hence there will be less chances of liquefaction during earthquakes, right? Next, there is a test, laboratory compaction test or the standard Proctor test, which we perform in the laboratory to find the maximum dry density of the soil, right? So what we do is soil is compacted into a mold in 3 to 5 equal layers, each layer receiving 25 blows of a hammer of standard weight, right? So we take a standard weight hammer and we apply 25 blows to each layer, right? The energy supplied in this test is 595 kilojoule per meter cube, right? The important dimensions are, so what the important dimensions involved in the Proctor test is we take the mold with a volume of 1000 centimeter cube and a hammer of a mass of 2.5 kg and the drop of the hammer is 300 mm, okay? So this is the these are the tools which are used in standard Proctor test, right? So there is a soil sample as you can see inside the mold and this is the mold, right? And we put soil in this, we put collar above it and then we fill it with soil, right? Then we use hammer, which is a rammer. Here's a rammer and the mold is laid on a base plate, right? So here are few dimensions, as you can see, dimensions of the tools we used in the test, right? So as you can see, there is a hammer with the dimensions of 300 mm drop, 305 mm drop, and in the modified test we use 457 mm drop hammer, right? And the hammer has a weight of 2.49 kg in the standard Proctor test and 4.54 kg in the modified test. And here is a sampler or the mold with the dimensions of 944 centimeter cube volume, right? So we use this sampler, right? So let's move on to the next step-by-step procedure of the test, right? So in step 1, we fit the collar and compact the moist soil in 3 equal layers by rammer and give 25 blows to each layer. So we take around 2 kg of soil and pass it through a sieve of 4.75 mm sieve, and we compact it in 3 equal layers and give around 25 blows to each layer, right? After that, we remove the collar from the compacted soil and even the top of the mold. So what we do is, there is a mold and there is a collar above it. So after in each layer we put 25 blows, and then we there is a soil, and then we remove the collar and we scrape off the soil above the mold, right, with a straight steel edge. Okay, so after that we clean outside of the mold and base plate and weight it. We take out the soil sample out of the mold and we weight it, right? After that, remove the soil from the mold and split it and take about 100 gram sample for water content determination. So what we do is, we take out the soil sample, we weight it, and after that we take around 100 grams of soil and we take it for the water content determination, right, in the oven drying content, right, oven drying method. Okay, after that what we do is, now we have water content with us. After this step, already we have volume of the sample, which is the volume of the mold as 1000 centimeter cube. Also we have the mass of the soil sample after compaction. So what we do is, we take density as mass upon volume, we substitute the mass here and the volume here, and we get the density. And after the step 4, we also know the water content of the soil sample. So ultimately what we do is, we find out dry density of sample, which is bulk density, which is, this is the bulk density, and divided by 1 plus water content. So now we know the dry density of the soil sample, and thereafter we prepare a chart in which x-axis have water content and y-axis have dry density, and we plot different values obtained in the test, right, and we connect those values, and after that we comes to know that at a particular water content our dry density is maximum, and this water content is known as optimum moisture content, and there you get the gamma D max. So while performing the field practical observations, we find the water content at which the gamma density will be maximum, so the stability of the structure will be maximum, right? So this was the test. Now let's come back to our question. They asked, why do we compact the soil? So basically we have 3 major benefits of the compacted soil. So the first is, it increases soil strength. So the soil strength is increased, as you know, as you can see, we have discussed earlier that since the void ratio is reduced, the shear strength will get increased, right? So it will increase the shear strength of the soil, right, which ultimately increases the bearing capacity of the soil. Also, if we make slopes on that soil, so the slope will have greater stability, etc. So these are 2 points which are in respect of the strength of the soil, right? So compaction increases bearing capacity as well as slope stability. After that, as you can see, the volume changes. So by compaction, the volume of the soil is reduced, hence the volume is reduced, which ultimately provides us with lesser settlement when we build our building over that soil. So settlement will be less. Along with that, swelling potential will also decrease, right? After that, as we have discussed earlier also, that the hydraulic conductivity will also decrease. So in case of earthen dams, as our main purpose is to reduce the hydraulic conductivity so that the seepage will be less and our dam will be stable. So by compacting the soil we can achieve that, right? So these are the main benefits of the compaction of soil. So to conclude our question, we can say that these three benefits we get by compaction of soil, and hence we do the compaction of the soil, right? Thank you so much for viewing us. That's all.